welcome to this tutorial video about defining basic construction elements in the shell expansion. We do this in MasterShip, and what we see here is a 3D surface model. And here on the right bottom, we see the shell expansion of this 3D model. We have made the shell expansion using this function, which is explained in the previous tutorial video. So if you want to see how to make the empty expansion from the 3D model, you can look at that video. And in this video, I already prepared some lines in this 2D expansion, but I also prepared some lines in the 3D model. So what we typically want to do is define basic construction elements either in the 3D model. So for example, I have here a girder, longitudinal girder, and I've made this using a polyline projection from the top view onto the shell surface model. And I could also have done it using this function. I think most users of AutoCAD functionalities or MasterShip functionalities will be familiar with this. And we can also define construction elements like those bulkheads indicated with yellow and transfer them to the 3D model. So we can go two ways. And another thing that could be interesting is to, for example, include reference geometry. So for example, those red lines, I've included them in a 3D model and they indicate where the flat surface area, so the bottom of the ship, transits into a curved surface, and that can be helpful for defining some parts in the shell expansion and to know where the transition is. So let's take a look on how to do it. The input that we need for transferring the curves is polylines. So let's start with 3D first. We have here the function 3D to 2D, and I'm going to select the girders, and I'm also going to select those longitudinal stiffeners, just a few, to convert them to the 3D model. I press enter, and the lines are automatically generated in the 2D expansion. If we look from the top, then we can see that those three girders or the longitudinal stiffeners really follow the contours of the expansion, and that is exactly what we would expect. Same goes for the girders. So here on the flat bottom, they are straight. But here at the end, where the flat bottom transitions into a curved surface, the girder in the 2D shell expansion also starts to curve away. And that's also what we would expect. Same here at the tip. So we could say this is approved. We see some differences here on the length. And we can explain it as well because we also see here some differences in the length. Then doing it the other way around, therefore I define some bulkheads in the 2D model. It goes practically the same. You select your curves and you press enter and they are transferred into the 3D model. So now we have here the front bulkheads, and it reaches until this deck line, for example, which is also the case here. And in this way, you can very easily and quickly make your shell expansion out of your 3D model, or define your 3D construction elements in the 3D model from the shell expansion. You can do it with a lot of different things. You could also, for example, draw a circle here and then convert it back. Or maybe if you want to go detailed, you make you project a circle here as a bow thruster in a 3D model. And then when these lines are projected, you can convert it back to the shell expansion, for example. This concludes this video on how to define basic construction elements in the shell expansion drawing. I thank you for watching, and I hope to see you in the next videos.